Okay, this is a continuation of uh, our discussion last meeting, in the last video. This time we're going to determine the derivative of the functions that I have prepared here. Okay, yeah. So let's start with number 6. Okay, if you recall, it is always important to choose your u so that the function can be written in simpler form. Here, your u is obviously the argument of cosine, no, which is 5 theta. Okay, and then next step is to rewrite the function, replacing now your u. Okay, replacing 5 theta with u, so you have cosine u. So we can easily determine the derivative of this from our list of formulas. The derivative of this is g prime of theta equals, what is the derivative of cosine? We know that to be negative sine u, right? But don't forget to compute for the derivative of your u, okay, according to the chain rule. And then you have negative sine. You put back the u, which is 5 theta, and then the derivative of 5 theta, and then we have here negative sine 5 theta times the derivative of 5 theta, which is what? That's equal to 5, right? And we can write this as negative 5 sine 5 theta, which are derivative for cosine 5 theta. Okay. Number 7. Now, what is your u here? This is actually an exponential function, natural exponential function. And obviously the argument for the exponential function is the one that is in the exponent, no? So that means that your u is 4t plus 3. So that the function can be written as f of t equals e to the u. Okay. Having written that in its simpler form, we now find the derivative. So the derivative is f prime of t equals, now what is the derivative of e to the u? Okay, we know that to be e to the u, but according to the chain rule, don't forget the derivative of your u. Okay, which is e to the u. What is u? U is 4t plus 3, then times the derivative of your u, which is 4t plus 3. And we have here e to the 4t plus 3 times the derivative of 4t plus 3, which is 4, right? And you can write your answer as 4 times e to the 4t plus 3 for the derivative of e to the 4t plus 3. Next problem. Okay, number 8. This time we have f of x equals x minus cosine x to the 5. Whenever you have a function, certain function that is raised an exponent, the one that is inside the parenthesis, no, is the obvious choice of your u. Okay, and then your f of x can be written now as u raised to 5. And this particular form has a derivative of what? 5 u to the 5 minus 1, which is 4. But don't forget, according to the chain rule, compute for the derivative of your u. So we can write this as 5. Let's put back the u, x minus cosine x times the derivative of your u, which is x minus cosine x, and then we have 5, sorry, I forgot to indicate the exponent here, so you have 5 times x minus cosine x raised to 4 times the derivative of x minus cosine x, which is the derivative of x, which is 1, minus the derivative of cosine x, which is negative sine x, right? Okay, and simplifying, we have 5 times x minus cosine x raised to 4 times 1, this one will become plus sine x, and you can multiply 5 with 1 plus sine x, so you can write this as 5 plus 5 sine x times x minus cosine x raised to 4. We have the derivative for f of x. Okay, 2 more problems. This time I will try to compute the derivative without necessarily identifying RU. When you master the process, you don't need to write the u specifically. You can just proceed to computing the derivative immediately with the value of your u just in your mind, no? So obviously your u here is cotangent, right? So that means that you have y equals e to the u, and the derivative of that is, the derivative of e to the u is e to the u, where your u is cotangent x. Okay, and then according to the chain rule, don't forget to compute for the derivative of your u, which is cotangent x. So you have e to the cotangent x. Derivative of this is, check your formula, that's actually equal to negative cosecant squared x. So you can write your final answer as e to the cotangent x times cosecant squared x. You are actually saving some space when you don't write the u anymore. Okay. Okay, last problem. Again, whenever you have a trigonometric function, check for the argument of that. That would be your u. Okay. Although sometimes the trigonometric function is an argument also of another functions, just like in number 9. But in number 10, obviously your u is e to the x. So if your u is e to the x, then the derivative of that is the derivative of cosine u, which is negative sine u. Your u is e to the x. But according to the chain rule, don't forget to find for the derivative of your u, which is e to the x, and then you have negative sine e to the x. What is the derivative of e to the x? That's e to the x, or you can write your answer as negative e to the x sine e to the x. So that's it. I hope you can answer the exercise that I've given to you. Be sure to submit it as soon as possible. God bless.